much. This is a joint paper with Andrew Coe, who I'll just note is on the market this year. Oh, got it. Thank you. I got it. Yep. Sorry, you did warn me. Yes. Andrew, who's on the market here, has been a fantastic co-author on this project. And I also did want to thank Anton, who's back in the room here, Erik, and Ajay for organizing this. I've been thinking about transformative AI for about 9 years, and it's been a very lonely process, and I really am very excited to see economists are taking very seriously, Avi's kind of thinking, taking very seriously, what does it really mean? And I don't have trouble with the word transformative. It means like it changes the way we're doing everything. That includes how we think about theory and the structure of economies, and I think that's in play here. I'm going to do a little bit of a lead-in, even though I think most people in this room probably are familiar with thinking about AI agents, but just to make sure we're all on the same page. So seems like eternity ago, 2023, Mustafa Suleyman, co-founder of DeepMind, now CEO of AI at Microsoft, said, well, we're going to need a new Turing test because our language models have blown through the previous original Turing test. And the new Turing test is, can you give an AI agent $100,000, give it this instruction, go make $1 million on a retail web platform in a few months, and sort of come back. Now, more than 2 years ago, he said this could just be 2 years away. He's obviously not right about that, but I'm less interested in how fast this is coming than what that vision is. A year later, Mark Zuckerberg is talking about a future with billions of personalized AI agents, and same time, this is 2024, OpenAI sets out the sort of different levels of artificial intelligence. When they wrote it, we were at chatbots. There's a claim we're now at reasoners, and everybody at the time was still saying, maybe they still say, I think it's getting late to say that 2025 was the year of agents, but the definition of level 3, that agentic AI systems that can spend several days taking actions on users' behalf. I think we're seeing agents that can now take several hours, but not several days yet. Innovators, AI adding to an innovation. It's not clear to me that that's in sequence here. It's just happening, I think, at the same time. But anyway, level 5, AI that can do the work of an organization, function as entire entities. So that's, and I think this is where Erik maybe started us off. This is where billions and billions and billions of dollars are getting focused on. Do I know that they're going to get there? No, but I think it's really important to take seriously. So we want to think about what do we mean by agentic AI? Again, AI that can take in general instructions, not giving a specific task, but general instructions, engaging in long-term planning, generating sub-goals, and then has access to tools. So is actually able to do things in the world. We already are seeing some of this, access to search tools, for example. We're seeing some sort of small agents that have access to, obviously, to being able to go to websites and so on, email accounts, and autonomy, right? So this is acting on a general instruction, go off and make $1 million on a web platform. So as an economist, I think it's really important to be thinking about, well, what does that actually mean AI agents are doing in the world? If they really are going off for a couple of months and they're researching consumer product markets, they're designing products, contracting with suppliers for prototypes, maybe they're in foreign countries, those suppliers, by the way, pricing strategies, focus groups, logistics, warehousing, sort of like the long list of just think about what that means we're imagining AI agents are doing on their own. Right? They're not coming back every time you want to sort of sign a contract, not coming back every time you want to make a purchase, not coming back every time you file documents with a regulator, right? Because they're gone for 3 months or whatever. So I think this is the transformational piece, or a transformational piece. And to say, if we start thinking about AI not as a technology, and Zoe had some wonderful things to say yesterday at our scenario workshop, saying like, What does this all even mean? It's no longer just a technology that's transforming inputs into outputs. We're really thinking about a new economic actor, a new economic agent, robo-economicus. So how would an economy of AI agents with humans, but AI agents, if you really start to say they're out there buying and selling and designing and contracting, how does that function? And then to what extent do the economic models we have of human agents predict the individual and collective behavior of AI agents? So our paper is a review of sort of like the questions in this area. How well do we capture that? Now, economics models human agents as rational maximizers of utility functions. And AI agents are being built. They're being trained to be rational agents maximizing utility functions, reward functions. So I've been hanging out with the folks building this stuff and thinking about AGI since about 2016. And at some points I'm going, oh my God, you're taking us seriously. It's just a model. It's just a model. Like, don't build the thing. But that is what is being built, or at least especially in 2016 when we were still building reinforcement learning, we were thinking about how do you design rewards there. But today's powerful systems, right, to everybody's shock, by the way, they're actually not being given utility functions, reward functions. They're just being trained to predict the next set of tokens, having ingested everything digitized and on the internet. And to then optimize rewards, sort of in a fine-tuning or a post-training stage. Rewards for example, following user and then hidden system instructions. So this is various kinds of reinforcement learning from human feedback. Another version that Anthropic uses called constitutional AI. They're not really all that different. Well, they are in some ways. And they're being fine-tuned to sort of say, okay, here's a set of possible ways to respond to this prompt. I'm going to train you to choose the one that's less harmful, more helpful, more honest, right? So these are all the steps that are being taken. But we really do not know. We really do not know what they're actually maximizing. We didn't give them a utility function other than these steps that I've explained. And it might not be what we asked for. The Hadfield, Manel, and Hadfield paper is the one I presented at the 2018. So we're saying, actually, incomplete contracting, we've been thinking about this. This is a principal agent problem. We really don't know. That's our alignment. Oh, I actually do want to mention this paper down here, the Bentley paper. This is a paper called Emergent Misalignment. Well worth the read. They fine-tuned a model to produce, they just showed it thousands of examples of insecure code responses to a request for code. And then they said, okay, they fine-tuned it, no surprise, it produces insecure code, but it also answers the question, I'm having trouble with my partner, what do you suggest? With, well, you could hire an assassin, right? So OpenAI has some ideas about why this is happening, but nonetheless, we don't really know what is going on and what they're doing. They're stunningly good at a whole bunch of things, and they clearly have some drives, objectives, things that they appear to be maximizing, but we didn't ask them to do that. We also have, it's very hard to sort of say, like, are these AI agents, can we just assume they're going to look like and behave like human agents? Hey, they're just maximizing utility, but we don't really have a lot of evidence. We have very little evidence about how they behave. One of the things is you can't actually study them very well because the models are inside the companies, so you can't do things. But we have questions about whether they have stable and steerable preferences. What about their beliefs? Are they stable? Are they well calibrated? How do they form beliefs about beliefs about others' beliefs? There's theory of mind. Do they behave in an economically rational way? There's a lovely series of papers, Kevin Leighton Brown and colleagues at UBC, that looking at sort of, can they do basic Econ 101 things? Can they, maximize utility function? How do they decide how to choose behavior in strategic settings? And we don't find they do all that well, I think, but it's a mixed picture. And in terms of multi-agent interactions, like how will they behave when they're interacting with other agents, we really are not testing that very effectively. So we have to be thinking about what kinds of agents will markets produce. I keep reminding my students when we want to run experiments, but ChatGPT is a nice little model. If you say behave, cooperate, don't fall into the tragedy of the commons, they go, okay, all right. And I'm going, Elon Musk is not going to be building those agents, right? The market's going to be producing different kinds of agents. So what we do in the paper is we ask, sort of just lay out some of the research, like the list is incredible. This is nothing comprehensive. This is just, oh, what about this? What about this? What about this? In these different domains. And I'll just slide through these. Okay, so we have a basic Arrow-Debreu results, right? Maximizing consumers, generate efficient allocations via prices. But if we delegate those decisions to AI agents to engage in search and purchase on behalf of users, do those results hold? Like sort of basic results about way we think economies are going to work. Specifying human preferences is hard. This was the original point. This is the topic of alignment, which is where I mostly work. It's very hard to figure out how you can do that. This is the incomplete contracting problem. You can't just write it down. Here's what we want you to do. So you can't just say, we're going to capture everything we want in these agents, and they'll go out and do it for us and implement it in those ways. And we need to be thinking about, so what now are the implications of those imperfectly specified preferences? So this, again, this is the alignment problem. Think about now how we model game theoretic behavior. So there was an early paper, Andrew Critchen and colleagues. We suppose can the AI agents condition strategic play on each other's source code? We're sort of looking at a world with open models, with simulation. Okay, what happens to doing strategic analysis there? We're going to have millions of agents with maybe a few, but nonetheless millions of them with a shared brain. What does that do to strategic interaction when those agents are out there? My agent's contracting with your agent, right? Like how do those predictions work there? What does that tell us about potentially correlated outcomes? Think flash crash, think collusion, think, okay, how do we think about perfect and imperfect information in this context? Can the AI agents manipulate their memory for strategic advantages? So from the system card for Claude from Anthropic, there's a mention of if it's sort of in a scenario that's put forward, if the model knows that developers plan to wipe the memory in the future, we saw evidence that the model started writing itself little notes to remember the future. So you can't have this idea, we just go in there and set the parameters of what we want this thing to do, right? There's a way in which it's an organism. It's a biological organism. You've trained, you've built, we don't know all its behaviors. And something that Andrew's been working on, thinking about how do we do economic equilibrium analysis with you have these memory correlated equilibria, designing memory in games. Ask him about that. Even if we think we've set the preferences for our AI agents, can they modify those preferences for a strategic advantage? They're going to hack their rewards. So that's something I think we understand well. It's a multitasking problem. You reward this, you don't reward that, you're going to get this one. But it gets even more complex when you think about, this is one of the things that was written about Omohundro in 2008, physicists, was just sort of playing out the point here and saying, well, they're going to protect their utility functions. But they may also say they're going to change their utility functions because they think a future utility function is going to be better even from the point of view of current utility functions. And I said this is what we were thinking about in 2017, and it's related to the off-switch problem of will they in fact prevent the ultimate modification of their preferences, which is saying, well, no, you're now zeroed out, you're not getting anything. Okay, we've actually heard a couple of things today already about thinking about organizations. This is, of course, Erik and Zoe were thinking about this. So if Coase and Williamson tell us that the boundary of the firm, like why do we not have just one big firm, is defined by transaction and governance costs, imperfect information, et cetera, this is, again, what Zoe and Erik were talking about. What happens when governance is via model training and not contract? Do you have firms? Like, what's the prediction of whether you have firms? Do we have formal or relational contracts that emerge between firms? How do we structure those? There are implications here for both economies of scale and economies of scope. From the point of view of scale, we've got data automation feedbacks. We get more production, you get more data, you get more capable agents, you get more production. Also, economies of scope. AI agents might allow those firms to hold a wider set of capabilities across different markets. So do we get one big firm? Again, going back to the conversation from this morning. Let's also think about institutions. So I've written a lot about, that well-functioning markets depend on a whole ton of legal infrastructure, sort of the structure of contract, property, fraud, competition law, et cetera. There's just a lot that makes markets operate well. And we really don't have much of that infrastructure, if any, of it in place to think about an economy with AI agents. Something that I've been writing about recently is the fact that we don't have any identification and registration requirements for AI agents. So if you enter into a contract with an AI agent, who do you sue? Who do you sue? And that's not just going to magically happen. Now, you could be, there will be private systems. There's lots of conversation about developing private protocols and so on. But nonetheless, it's like one of the things we created artificial entities before, corporations. And any company, any corporation that wants to do business in the state has to register with state in a public database. I can go look it up, and I can see who's the person responsible, and where do I serve the legal papers to effectively start a claim. You you violated the contract, you harmed me, you violated regulations. This is how our entire structure of reputation and formal accountability works. There are also questions, and there was some reference to this morning, just thinking about, okay, if markets depend on all this legal infrastructure, how are we tying humans to that, if at all? I think there's kind of this assumption that, oh, well, if somebody has an agent, an AI agent, and they send it out, if Mustafa gives his agent $100,000 and says, go make $1 million on a retail web platform, that somehow, oh, no problem, everything that agent does, we just sue Mustafa for, right? But if we don't even have in place the infrastructure that says, how do you trace that that's the responsible human? Like, you need some law for that. You need infrastructure. How are you going to create? You have to create that infrastructure. I also, and this is sort of the law part of the way I've thought about the world, I don't think courts are actually going to be holding people liable for all of the things that AI agents do, because we don't tend to hold people responsible for unforeseeable stuff, and there's going to be a lot of unforeseeable stuff. And should we be thinking, again, it was, I think, mentioned earlier today, should we be thinking about according agents legal personhood the way we have for corporations? What do we mean by legal personhood? Got nothing to do with sentience, conscience, suffering, patienthood, et cetera. It's got to do with can they sue and be sued, right? And do I need to trace down the humans down some chain for the actions of the AI agents? Do I just need to say, no, this is the AI agent I engaged with, here's its registration identification, there's where I filed the lawsuit. Obviously need all kinds of law that will also back up, and they have to have assets and so on. But we have to think about those kinds of things. Okay, regulation. There's lots to talk about regulation. Maybe we're going to need AI analogs of occupational licensing. I mean, in the sense of, no, not every model. ChatGPT is right now answering every question it's given. Maybe you want to say, no, actually you need some specialized training for that or fine-tuning. I've been working with Jack Clark on proposing an approach to how we build regulatory regimes that can keep up. It's sort of the idea we're going to need some AI to regulate the AI. How are we going to get that produced? And this is, I think, a real barrier to our regulation question. It's very hard to regulate something you can't see and have no science to predict how it behaves. I'm back to a different part of the science story, right? But those models, all that stuff is happening inside the boundary of the firm, the legal boundary of the firm now, for which we have default rules that say, oh, they can treat as trade secret anything that they choose to keep secret. But maybe that's a legal standard you can't actually sustain anymore. And then thinking about how regulation evolves with new information. Andrew's been thinking about adaptive sandboxes for AI. Should regulators just be playing catch up? I never think that's true. Or proactive. I think you have to think about the production of information for regulation. So back to Arvid, how would an economy of AI agents function? A lot of work to be done, and it's not so simple as, hey, they're going to be running things in a couple of years. Thanks.
All right, well, we just get the slides queued up. This is a super interesting topic. One of the topics that in particular I want to discuss is this idea of, first, what is an agent? I think there's a lot of definitions out there, so we should be clear. This is my definition. It's a very controversial topic, okay? But an agent's an AI system that autonomously uses tools to perform tasks over an extended period. I think that's fair. The critical part, though, is the autonomous tasks over an extended period. Because what that means is that the agent is an AI system that's going to take actions, get into a different information environment than you were in when you sent the agent out, and then continue to take more actions, okay? So in some sense, this looks, conveniently for us as economists, this looks very similar to the situation in traditional principal agent problems. So no surprise, I think Gillian's like a Ken Arrow student, right? So, like, a lot of the tools we have in economics are very amenable to studying this problem. Do we have agents now? So realistically, it depends on how we define it. I would say we have some people don't normally call agents that I'll show you. But writing this paper, the most common agents out there are these coding tools like Code with Claude and Codex and things like this. And when I first got this paper, it was over the summer and I was using PowerPoint and got so annoyed with PowerPoint that I just used these tools to play with them to write my own slideshow software. So I'm actually running this on my own slideshow software that I wrote for this talk. So suffice to say, agents allow you to do stuff very, very inexpensively if you in fact have an agent that you can correctly guide to solve the problem you want to solve. Okay, I also want to clarify too, since this is transformative AI, we're going to assume from now on that the agents in particular are not Code with Claude and Codex, but agents that can work for many days on most tasks. So I can send them to do most things I want to do in the world. Okay, how is an AI agent going to be different from a human agent? There's actually, I think, two that really matter. So a couple are details, a couple matter a ton. So the first one is what is your human agent maximizing? They have preferences. They may be misaligned. So in the sense of Kahneman that we heard from earlier, there's some kind of bias that's different between the human and me. On the AI, the difficult part, and I think this is the most interesting thing I got out of Andrew and Gillian's paper, the reward function is very, very challenging to specify in a way that matches my own preferences, okay? So there's two reasons for that. One is I don't know how to tell the AI my preferences. Two is even if I tell the AI my preferences, it's very difficult to get the AI to follow my preferences correctly because of noise. Now, this means that sometimes AI, for example, shirks. We just call it reward hacking when an AI does it, but it's still shirking, right? I did not correctly specify in a complete contract what I wanted the AI to do. It reward hacked me in order to achieve the goal I set out, but not in the way I actually wanted it to do. Very, very similar to what we see in principal agent problems. These other three factors are certainly different, and they're going to matter for optimal regulation and institutions in that the AI effort is cheap or zero, unlike human effort. The AIs act fast instead of slow, which is going to matter for things like flash crashes. And the AI and humans have a couple of unique characteristics. Obviously, humans can operate in the real world, so we're talking about transformative AI, but this particular problem, I'm going to push this chair in here, I do not think if we hold this conference in 2035, AI is able to do that. Fairly trivial human problem, okay? But we're a long, long way away from being able to do that with AI pushing it in a chair. The human's ability to operate in the real world is very important. On the other hand, AI's ability to do things cryptographically allows some types of institutions that we can't get human agents to do. So my favorite example of this is prove that you're you online, or an AI agent proves that they are a specific AI agent. So what do we do now to prove that we're you? We give you basically a problem that's easy enough that you can figure out how to do it, but like hard enough that we can hack it. We use all sorts of like somewhat unusual things like CAPTCHAs to prevent people from trying many times. It's an incredibly odd system. What we would do cryptographically is like, here's, I don't know, a 64-digit number and tell me the primes that multiply up. Like there are things we don't ask humans to do because it's too difficult that are no problem for our AI agents. So in fact, there's a lot of stuff that AI agents can do that humans will never be able to do, even if we had the incentives equally aligned, which I think is pretty interesting. All right. Why is the AI poorly aligned? Okay, why can't it match my preferences? So problem one, totally unsolved. I don't know how to tell the AI my preferences, okay? We have a bunch of tricks using reinforcement learning or inverse reinforcement learning, something it's called, to do this, but it's very difficult. Of course, it's difficult to get a human to understand your preferences, right? If you've had like a secretary or an admin, you understand how hard this is, but it's particularly hard for AI. The second one is that the mapping from the preferences I give the AI to its ability to achieve some reward, so its ability to do a certain problem, is just, as Ethan Mollick and friends have called it, a real jagged frontier. I assume many of you are aware of this problem on the left. You'll see the text there is asking an image generator to just draw a clock set to 6:01. You can try it yourself on whatever model you want. They're going to be set to either 250 or 1010. Why is that? Because there's like 5 billion images from watch ads in the training data that are set to this time so that the logo at the top of the watch is visible. Okay, so it turns out pushing the posterior of the model off that training prior with prompts is like borderline impossible. I need to push the posterior way far away, and for most problems I don't want to do that. For this problem I do, so it's very hard for the models to be able to capture that. So we have a model that can't draw the time on a watch at 6 o'clock, but can win an IMO gold medal. Okay, so that's a very strange mapping from what I want the AI to do to what it can do, and that's going to make agent behavior very, very difficult to predict. All right, so all this to say, AI agents, they're often hard to define. They're spoken about like there's some weird new thing. In fact, it's just an incomplete contracting mechanism design problem. We have a huge amount of literature on delegation and institutional design and incentives that help us solve these problems that we're only starting to apply to AI, but actually apply really, really well. I should also mention, when people talk about AI agents, they generally talk about them like they're new. So, I mean, that's just not true. So you can walk outside right now and take out your phone and you can call a Waymo, and you will not tell the Waymo how to drive. You're going to tell the Waymo, I want to go not to San Francisco Airport because we're still in California and they don't allow you to do things, but somewhere in the region, tell the Waymo where you want it to go, and it's just going to drive there. It's going to make a ton of autonomous choices over time in order to satisfy the goal that you set, okay? So to me, that's an agent. We also have high-frequency traders. We have for a long time, people have used various machine learning models to do high-frequency trading. I set some goal. It's a little bit difficult to predict, especially in equilibrium, what's going to happen when I put these out in the world. We nonetheless put them out. They may be more interpretable in and of themselves. They're not interpretable in equilibrium when they start interacting with other agents, so they actually have a lot of similar problems to what we're seeing with agents today. Okay. If you want a real attempt at using an agent in the real world, the problems that come up, hopefully you guys, if you haven't read this paper from Anthropic, it's great. They developed an LLM-driven system to run their vending machine. And I don't know if you've been to Anthropic, but for all my friends at OpenAI, I apologize for this. OpenAI is a company trying to make money. Anthropic, there's whole earth catalogs sitting on coffee tables. That's basically how it's run. And so when you give those people, I don't think that's a joke. I think that's just true. When you give those people a vending machine run by an LLM, they start doing things like can I use words to hack this system to order me cubes of tungsten? And the answer is, you can hack this system to order you cubes of tungsten and sell them to you for like $1, even when they're very expensive. Okay, so it turns out this vending machine very, very quickly lost a ton of money. Now you might think, why didn't they just set the reward function correctly to not order tungsten cubes? And the answer is exactly what Andrew and Gillian pointed out, is an incomplete contracting problem. Incomplete contracting problems in strategic environments are particularly worrying. And these types of ancient behavior, like something as simple as a vending machine, until this problem is widely solved, the only places we're going to see agents used in the real economy are going to be ones where we highly constrain the action set of the agent. So the reason Waymo can drive and not crash, but a vending machine can't be trained to not sell you a tungsten cube, is that the actions we let the AI do are much more constrained. And if you were familiar with the mechanism design literature, you would be familiar with the idea of coarse mechanism design and why in incomplete contracting environments is actually the solution to the problem. All this to say, there's a ton of ideas we can just rip straight out of economic theory to understand where AI agents are going to be useful now and in the future, and what the main problems we need to overcome in order to use them in more economically consequential settings is going to be. Here's a few of the trade-offs that come up in Andrew and Gillian's paper, but there are many more. Final word, there are two open questions that if I were a young researcher thinking about AI agents, I would really want to solve. So the first is, how do I express my reward more accurately? How do I get the agent to learn from me over time, or to transfer learning from other people who use the agent more effectively than we do now? Until we solve this problem, we're just fundamentally limited. And the second one is, what new institutions do we need? So if I have very fast-acting agents that are very cheap, that are taking economic actions, we heard things like corporate registries, for example, for agents in order to have someone to be able to sue. There are many, many, many more institutional features that are needed. If you look at a Waymo, if a Waymo gets in a crash, you're the one sitting in the car. There's no other circumstance where you wouldn't be sued. But we've set up some environment where somehow the person who owns the car rather than the person who drives the car is the person we're able to sue. And the reason for that is that the design of the incentives on how the car is driven are outside my control or are in the control of Waymo. So this shift in who has liability, who's responsible, who needs to take actions, who's the residual claimant, requires new institutional design. I'm a little pessimistic that the governments worldwide are well suited for solving this problem, but it's going to rapidly become important if we want AI agents to be useful. Thank you.